Okay, in this lesson we are looking at relative position for data sets. The most commonly used measures of position are quartile, percentile, and standardized values. These are called measures of position because they describe where the data items are in the list, ordered from smallest to largest. So let's first look at quartiles. And the good news is that we learned about these in the earlier section. We learned how to find quartile 2, which is the median of the entire data set. And then quartile 1 is the median of the lower half of the data set. And quartile 3 is the median of the upper half. Okay, so there's our quartiles, 1, 2, 3. Percentiles. A percentile is not the same thing as a percent. A percent tells us what the part of a total is. A percentile tells how many data values are below that position in the set. Okay, the better news about percentiles is that percentiles and quartiles are basically the same thing. So we already know how to find 3 of the percentiles. The 50th percentile is the same thing as quartile 2. Sorry, I'm going to do the same colors I had up above. The 50th percentile is the same as quartile 2. The 25th percentile is the same as quartile 1. And the 75th percentile is the same as quartile 3. Okay, well, those were easy. What if we want to find something different than those 3, like the 80th percentile or the 11th percentile? All right, so here's the steps for finding data associated with a given percentile. First thing you're going to do is make sure that the data values are arranged in order from smallest to largest. Okay, the second thing you're going to do is you're going to multiply the number of data values by the given percentile as a decimal. Okay, so that's pretty easy. But this is where it gets a little tricky. Finding the data value depends on whether the answer from the second step is a decimal or a whole number. If it's a decimal, round up to the next whole number to get n. In your list, count n numbers from the smallest number. When you get to n, that's your answer. Okay, that's the easier one. If it's a whole number, call it n and count n numbers from the smallest number. When you get to n, write it down. Go to the next value, n plus 1. Write that down. Find the average of these two numbers, meaning you add them together, divide by 2. Okay, technically, this value is usually not actually one of the data values. Okay, here's an example. Find the 70th percentile of the following data set. Okay, so first I'm going to make sure it's in order from smallest to largest. And then I'm going to take 70th percentile is 0.7, and I'm going to multiply that by 1, 2, 3, 4, 5, 6, 7. There's 8 data values. So 0.7 times 8 is 5.6. Okay, so this is a decimal, so I'm going to follow the first set of rules. I'm going to round 5.6 up to 6. And it doesn't matter what this value is. Even if this had said 5.1, I would have rounded up. All right, so now 6 is the number, so n is 6. So I'm looking for the 6th number in my list. 1, 2, 3, 4, 5, 6. So the 70th percentile is 37. That means that 70% of the scores are below 37. Okay, let's look at another example. Find the 26th percentile of the following data set. Make sure it's in order from smallest to largest. Okay. I'm going to take 0.26 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3.38. Okay, so I'm going to round that to the next whole number, which is 4. I'm looking for the fourth number. 1, 2, 3, 4, 20. My answer is 20. Okay, let me take this same one, and let's just say that when I did my multiplication, well, I can't use, let's just say when I did my multiplication, I got a whole number. So let's say that I had n equals 8. If when I do my multiplication I get a whole number, I go to the 8th number and the 9th number and I average them. So my 8th number, 1, 2, 3, 4, 5, 6, 7, 8 is 70, and my 9th number is 74. So I would have taken 70 plus 74 and divided them by 2, and then I would have gotten 72, and that would have been my answer. If I start with a whole number from my division. Okay, so that is percentiles. The next thing we're going to look at is standardized values, or z-scores. Standardized values is defined as the number of standard deviations a data item is above or below the mean. So if z is negative, the data item is below the mean, and if z is positive, the data item is above the mean. To find a standardized value, we have a formula. Z equals value of a data item minus the mean of the set divided by the standard deviation of the set. Okay, so here's my set: 12, 15, 13, 20, 10. I'm told that the mean of the data set is 14 and the variance is 14.5. Find the z-score for each of the following data items. So I want to find the z-score for 20. So z is equal to the data item 20 minus the mean 14 divided by standard deviation. Remember from in an earlier lesson we looked at the relationship between variance and standard deviation. Let's do this in green. So my variance is 14.5. My standard deviation is the square root of that number. Okay, so if you're going to type this in your calculator, make sure you put parentheses there or hit the equal enter button after the subtraction. So 20 minus 14 is 6 divided by the square root of 14.5. 1.5757 ... I don't have a rounding. Let's just round this to the nearest hundredth. I get 1.58 is my z-score. Let's look at another example. 12. Okay, my mean is 14 and my standard deviation is square root of 14.5. Okay, so the z-score of a data item equal to 12 is 12 minus 14 divided by the square root of 14.5. So 12 minus 14 is negative 2 divided by the square root of 14.5. Negative 0.52522 So that would be negative 0.52. Okay, in this next section, we're just going to practice our calculators. Some calculators have a percent button on them so that you could actually just type 312 times 26% using a symbol, or you change the percent to a decimal and you multiply 312 times 0.26. Either way, you get 81.12. Okay, if you have the percent key, try typing that 18 times 90 and then find the percent key. You get 16.2. Okay, critical thinking and logical reasoning. Every single section of our book has this section to it. Give logical reasoning explaining what is wrong with the following procedures regarding the z-value of a data value that is 70 taken from a sample with a mean of 80 and a standard deviation of 8. Okay, so in calculating the z-score in the first example, now I've already told you that it's wrong. There's something wrong with it. Try to figure it out. Z-score is equal to 80 minus 8 over 70. 80 minus 8 is 72, and 72 divided by 70 is 1.03. The math is correct. The formula is used wrong. Okay, it should be data value is 70 minus the mean, which is 80, divided by the standard deviation, which is 8. So they just had the numbers in the wrong place. Okay, so for number 2, same thing, there's something wrong with it. Well, they have 8 in the right place, but they have these two switched around, and the first number is not in the numerator either. Numerator should be 70 minus 80, all divided by 8. Okay, next page. All right, now we're not explaining what's wrong, we're explaining how to solve. Okay, so explain how you would determine whether the number k that ranks at the 78th percentile for a given ordered data set with 11 items is the value of a data item or the mean. Okay, this would be, if it's a decimal, you round up and you count to that number. You do the mean if you get a whole number, then you go to that number and the next number and average them. So if the product of 0.78 times 11 is a decimal, we use the value of a data item. If it is a whole number, we will use the mean of 2 data items. Okay, next example, explain how you would solve for the value of a data item whose z-value is 2.4 in a data set with a mean of 15 and a standard deviation of 5. Okay, so our z-score is data minus mean divided by standard deviation. So what I'm looking for, let me get my highlighter, is the value of the data item. I'm looking for this. So if I'm remembering back to my algebra, I multiply both sides by standard deviation. So my first step would be multiply well, let me actually put the numbers in. Well, z-value and standard deviation. So that would be 2.40 times 5. Second item. Okay, so now when I do that, again, if you remember your algebra, now I have standard deviation times z-score is equal to data minus mean. If I'm solving for data, I have to add mean to both sides. So then my second step is going to be add mean. So now I have 2.40 times 5, and then I'm going to add 15. That will give me my value of the data item. Okay. In these types of problems, I'm not asking you to find the answer. I'm asking you to explain to someone how you would get it. All right. The rest of these problems we are actually solving. Okay. Here we're looking at percentiles. For the ordered data list below, there are 20 items. Find the number k that ranks at each of the following percentiles. Okay, so the list is already in order from smallest to largest. I'm going to take my decimal 0.28 and multiply it by 20. I get 5.6, which is a decimal. I round that up to the next whole number, which is 6. I'm looking for the 6th number in the list. 1, 2, 3, 4, 5, 6, that's 25. 25 is at the 28th percentile. Okay, let's look at number 2. The 90th percentile. I take 0.90 times 20. I get 18. 18 is a whole number. So I'm going to go to the 18th number and the 19th number and average them together. The 18th number is 64. The 19th number is 70. Add those together, divide by 2, I get 67. So 67 would be at the 90th percentile. It doesn't matter that 67 is not actually a number in my list. Okay, next example. Find the data set, has 22 items listed below. Find the number k that ranks at each of the following percentiles. So 28th percentile, so again I'm going to take 0.28 times 22. I get 6.16. I round that up to the next whole number, which is 7. I'm looking for the 7th number. 1, 2, 3, 4, 5, 6, 7, 23. Oh, I forgot to double check that it was in order from smallest to largest. Make sure you do that. Yep, so we're good. If they weren't in order, I would have to write them in order first and then do these steps. Okay, let's look at the next problem. I want the 72nd percentile. So I'm just going to do that here. Problem number 2. 72nd percentile. Let me just make sure that's right. Yep. Oop, too far. Okay, so I'm going to take 0.72 times 22. I get 15.84, which is a decimal. So I round that up to 16. I'm looking for the 16th number. Okay, so this was 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 42. Okay, next problem. Okay, solve each of the following problems for the z-values of the data items with the indicated values. Round your answers to 2 decimal places. Okay, so I'm going to write my z-score up here. Z is equal to data minus mean divided by standard deviation. Okay, so my mean is 54, my standard deviation is 3, my data value is 57. So z is equal to 57 minus 54 divided by 3, which is 1. Next one, the data item is 44. I still have a mean of 54 and a standard deviation of 3. So z is equal to 44 minus 54 divided by 3, negative 3.33, if I round to 2 decimal places. Okay, next one. My mean is 110 and my standard deviation is 6. For the first problem, my data value is 120. Z equals 120 minus 110 divided by 6. My z-score rounded to 2 decimal places is 1.67. Okay, my next example, the only thing that changes is my data value. 97 minus 110 divided by 6, negative 0.5. Okay, last page. Okay, the ages of 20 people selected to participate in a survey were, then they list all the ages. Find the number k that ranks at each of the following percentiles. Okay, so if I'm doing percentiles, I have to make sure that they're written in order, and I see a typo. This person is not 339. It's just 39. Let's make sure they're in order, from smallest to largest. Okay, so the 37th percentile is going to be 0.37 times 20, 7.4. So that's a decimal. Round that up to 8, and I'm looking for the 8th number. 1, 2, 3, 4, 5, 6, 7, 8 is 32. Okay, next example. I'm going to take the 23rd percentile, which is 0.23 times 20, 4.6. It's a decimal, so I'm going to round that up to 5. I'm looking for the 5th number. 1, 2, 3, 4, 5. That's 27. Okay, let's do another example with this because I don't think we've done enough whole number examples. So let's add a third number in here. Let's do the 60th percentile. Okay, so that would be 0.60 times 2, which would be 12. So I'm looking for the 12th number. and then the 13th number, and I'm going to average them together. So the 12th number is 41, and the 13th number is 43. 41 plus 43 divided by 2. So 42 would be my answer. 42 is the 60th percentile of that list. Let's do one more. I think I can squeeze it right here. Let's do the 35th percentile. Actually, I'm going to change my mind because that's really close to our first answer. Let's do the 15th percentile. So that would be 0.15 times 20. That gives me 3. So I'm going to look for the third number and the fourth number and average them together. The third number is 21 and the fourth number is 25. When I average them together, I get 23. Okay. The last two are z-scores again. The mean of the ages of 10 selected to participate in a survey was 28. So the mean is 28. Standard deviation is 4. Find the z-value for each of the following data items. Remember that z-score is equal to data minus mean divided by standard deviation. So for number 1, my data item is 21 minus the mean is 28 divided by the standard deviation is 4. I get negative 1.75. Okay, didn't say how to round it, so we'll use negative 1.75. Very last problem, the data value is 35, so my z-score is 35 minus 28 divided by 4. My z-score is 1.75, positive. Okay, that ends our lesson on percentile, quartile, and z-score.